Lesson 3.10, the chromatic number of a graph. The chromatic number of a graph is the fewest number of colors required to color all the vertices of a graph while making sure no two adjacent vertices are the same color. Remember, adjacent vertices are vertices that are directly connected to one another with an edge. Chromatic numbers can be used to categorize information into as few groups as possible. For example, the number of colors required to color a map so that no two countries sharing a border are the same color. Or to categorize or group data based on incompatibilities. For example, making groups so that people who don't work well together are put into different groups. There are 4 steps to determining the chromatic number of a graph. First, find the vertex with the highest degree and color it. If there's a tie, start with either one. Next, find the vertices adjacent to the one you colored. Starting with the highest degree of those, color it a different color than the first vertex, and continue on with the others. Use the same color for all of them, unless they're adjacent to each other. Use as few colors as possible. Of the remaining vertices, start with the highest degree and color it so that it's not the same color as any vertex it's adjacent to, using colors that are already used if possible. The number of colors used will be the chromatic number. Let's see what that looks like when we get to a real example. We're asked to find the chromatic number of the graph below. The first step is to find the degree of each vertex. A has a degree of 4, B has a degree of 3, C has a degree of 2, D has a degree of 3, E has a degree of 2, and F also has a degree of 2. From that, we can see that vertex A has the highest degree. Looking back at the process, it says that we're supposed to find the vertex with the highest degree and color it. In this case, we color in vertex A. The next step is to find the vertices adjacent to the one we just colored and give them a different color, making sure that no two adjacent vertices get the same color. We look for the highest degree that's adjacent to A, and we can see that both B and D have the degree of 3. So we'll go ahead, I'll color B as red. I can also color D as red. Now, other vertices that are adjacent to A include C and F. However, they're also adjacent to other vertices that are red, so we can't use the same color for them. We'll need to choose the next color. We'll color them in blue. We're now left with just one vertex left over, and that's vertex E. It can't be red, as we've said. However, it could also be blue. If we wanted, it could also be yellow. Either way, it's adjacent to vertices of different colors. Now we're going to look at an example where we're dealing with incompatibilities, in this case between people. So you're a team leader, you have a group of 5 people. You want to make small groups to complete a task. It doesn't matter if the groups are the same size, but you must make sure that people who don't work well together are in different groups. We start by making each of the people a vertex in the graph. Once we have the vertices laid out, we make connections based on their incompatibilities. We're told that Beth can't work with Sue. David and Jonas don't get along. Sue and Brian are incompatible. David and Sue also can't work together. And finally, Brian and David can't work together. This gives us our graph of incompatibilities. Now we need to follow the process to find the chromatic number. We look for the vertex with the highest degree, and it's both David and Sue tied for 3. We'll start off by making David yellow. The process says then to look for adjacent vertices, start with the highest one, and color them. So Sue is adjacent, color her red. Brian is adjacent to David, but he's also adjacent to Sue, who we just made red, so we have to leave him for now. Jonas, however, can also be red. Since Brian's adjacent to David, we need to give him color, and we'll make him blue. Finally, we're left with Beth. We have a choice with Beth as to what color we make her. She can't be red because she's adjacent to Sue, but she's not adjacent to Brian or David, so either color would be acceptable. This tells us that our chromatic number for this graph is 3. Try the next questions on your own, then come back and check to see if you got the correct answers. Let's look at another example. Determine the chromatic number for the graph below. First step is to look for the vertex with the highest degree. It's not too hard to see that that would be vertex B. We then choose a new color and look for the vertices that have the highest degree that are adjacent to B. We can see that both D and G have a degree of 3, and they're adjacent, so we can make both of them red. Vertices A, C, and E, and F are also adjacent to B, however, they're adjacent to D and G, so we can't make them red. We need another color to color them in. That shows us that the chromatic number for this graph is 3. Let's look at another example. Looking for the vertex with the highest degree, we can see that vertex D has 6 connections, so we'll start off coloring it. The next step is to look for the high degree vertices that are adjacent to it. We can see that F has a degree of 4, so we color it in. A is adjacent to D, but it's also adjacent to F, so it can't be red. B, however, is also a degree of 3, and it's adjacent to D but not F, so it can be red. Neither C nor G or E can be colored in because they're adjacent to red vertices. We need a third color, and again looking for vertices that are adjacent to D and high degree. A is 3, so we color it blue. E is also 3, so we'll color it blue. However, G, even though it's adjacent to D and is degree 3, it also can't be blue because it's adjacent to E. So we're going to need a fourth color for G. Now we're left just with C. We have a choice with C as to what color we color it in. It could either be blue or green. So the chromatic number for this graph is 4. Looking at this graph, we can see that the vertex with the highest degree is vertex D, so we start off giving it the first color. We look for the highest degree vertex that is adjacent to D. In this case, it is C. A is also adjacent to D, however, it can't be red because it's also adjacent to C. E, however, is adjacent to D but not adjacent to C. We still have some vertices that are adjacent to D but haven't been colored, so we can go ahead and color A and F to be blue. We're left just with one vertex left over, vertex B. It can be neither red nor blue, however, it can certainly be yellow. So the chromatic number for this graph is also 3. Try the practice problems on your own. Check to see if you're expected to submit them to your teacher.